We all get excited about new electronic gadgets, don't we? Imagine you buy yourself your favorite gadget, come back home, and open the box, ah, only to find the wrong item. I know that feeling. Delegation without verification? Not good. But wait, are you using AI coding tools and delegating writing code to them for you? Sounds great, but how do you validate your code? You might say, that is simple, you can write tests. But when do you write these tests? Before you generate the code or later? And what about the best practices? In short, how is introduction of these AI coding tools changing your workflow? I don't have answers to all these questions, but our speaker today definitely does. Hi everyone, thanks for joining in for another episode of IntelliJ Idea Livestream. I'm your host Mala Gupta. And now let me add our speaker to the stream. Hey Bouke,
Hey,
it's a pleasure to have you present with us today.
thank you for the introduction and thank you for having me. I really like to be on this live stream.
Thank you so much. The pleasure is all ours. I'm so looking forward to learning from you. And before I let you move forward with your session, quick introduction. Bouke works as CTO with CINQ ICT. He likes to learn new things and he loves to live codes during his session. That sounds interesting. So I think our viewers are already in for a treat today.
I'm looking forward to it.
What could possibly go wrong? we always say that before we
Exactly.
live code. So Bauke, before I let you take the stage in the session, you'll be talking about writing your code based on the test. Did you also try the other way around, or do people come and talk about this with you?
Sorry, can you again? I didn't totally hear.
Sorry. So in this session, you'll be talking about writing the test and then generating the code so
Yeah,
that you make sure the
yeah,
code is perfect. But do you also work the other way around, or do you
yeah.
suggest doing that?
Now, yeah, everybody says they do TDD, right? You should write your tests up front. And I try to do that, but I think it's really hard. So I have to be honest, sometimes I write my tests afterwards. And sometimes I let the AI generate my test. But this talk is about doing it the other way around. First test, then implementation.
Makes sense. So we'll see how it goes. And before I let you take the stage, I wanted to share some housekeeping details for everyone who's watching. Please use the YouTube chat to post your questions. We'll try to answer your questions as you post them. And the most important question, yes, this session is being recorded and it will be hosted to our YouTube channel. So if you haven't already subscribed to IntelliJ Ideas YouTube channel, now is the time to do so. And if you like today's session, which I'm very sure you would, do not miss to like the video. And with that, Bauke, let me add your screen to the stream.
Yes.
Yes, and I'll be backstage. Have fun.
Thank you. Welcome, everybody. Thank you for joining this live stream. Today, we're going to talk about TDD and Gen AI. And together, we're going to see if this is a perfect pairing. So I would like to start with a little introduction. Why am I talking about this subject? So my previous talk was called The Battle of the AI Coding Assistants. In this talk, I showed off features of different AI coding assistants. Think GitHub Copilot, JetBrains AI Assistant, but also good old ChatGPT. One of the features I showed off was the fact that they are pretty capable of generating tests. So how does that work? You write the implementation, you give the implementation to AI, and you ask for tests. In almost every case, the AI comes up with a happy case. In most cases, it comes up with edge cases. And if you're still not happy, you can ask for more. And like I said before, this works pretty well. After giving this presentation, somebody came up to me and said, "Hey, Bouke, I like your presentation, but why don't you do it the other way around?" And I said, "The other way around? What do you mean by the other way around?" And she said, "You write the test, you give them to AI, and you ask for an implementation." And I said, "That's an interesting idea. I don't know if it works, but I'm going to investigate." This investigation led to this talk. The second thing I would like to do is title this section. So let's repeat the title. The title is TDD and Gen AI, a perfect pairing. So there are three IT concepts in this title. And the first two, of course, are obvious. The first one being test-driven development, TDD. The second one being Gen AI. And the third one is a little bit hidden in the subtitle. And the third one is pair programming. So let's see if we can combine those three concepts into a new concept. But before I'm going to do that, I'm first going to talk about a minute about those subjects so we're all on the same page. Let's start with Gen AI. Now, ChatGPT is the most famous one. It was introduced a little bit more than 2 years ago. It feels so much longer, but it's only been a little bit more than 2 years ago. But a lot has changed since the introduction of ChatGPT. All major IT companies now have their own AI assistant, and they all have something in common. They all run on a technique called a large language model. This is what powers our AI assistants. So those models are pretty good at generating text, but also pretty good at generating code. And that's what we're going to do today. The second concept is test-driven development, TDD. People hold entire conferences about this subject, but for this presentation, I'm going to boil it down to write tests in advance. And this is better than the other way around for a lot of reasons, but there are two reasons I really like. And the first one is if you first write your implementation and then write your test will be biased by your implementation, and we do not want biased tests. Secondly, I really believe in the following. The more you think about something, the better the end result will be. So if you first write your tests, you think a lot about your implementation, and therefore you will write a better implementation. Also, it goes really well with pair programming. So let's talk about that. So pair programming is a really simple concept. You write software in pairs. You sit together with two people behind one keyboard and you fix bugs or you write new features. Normally we have two roles. We have the driver, that's the person sitting behind the keyboard writing the code, and the other person is called the observer or navigator, and that's the person who's giving live feedback on your code, and that's the person you can have a discussion with while you're writing the code. The thing that happens a lot as well when doing pair programming is one person writes the test, you switch chairs, and then the other person will write the implementation. So let's see if we can combine those three concepts into something new. Let's see if we can create a perfect tripling. So the idea is as follows. We're going to pair program with Gen AI. The human will write the test, and the AI will try to write the implementation. And I call this test-driven generation, TDG. So something we didn't talk about a lot is the fact that tests have a double purpose in this idea. And we already talked about the first purpose. The tests are used as input. So you write the test, you give them to AI, and you ask AI to come up with an implementation that will pass this test. But the second purpose is that we also going to use those tests afterwards to check if this implementation is a correct implementation. And this is really important. You all have been playing with LLMs in the last 2 years, and you know they sometimes make things up. Let me tell you a story that really illustrates this point. So this was at the beginning of last year. There was a company called Air Canada, which is an airliner. They have a website, and on their website, they have a chatbot. And they decided to improve their chatbot by using a large language model. And this in itself is a proper idea because your chatbot will give more natural, more human-like answers. So a customer was chatting with his chatbot, the improved new chatbot with the LLM inside, and they were talking about refund policies. And as you will probably already imagined, the chatbot started to make things up. It invented its own refund policy. The customer was foresighted and made screenshots. Then some weeks, nothing happened until the customer decided to make use of his refund policy. He wanted to refund his ticket. He called the help desk with actual humans behind it, and he said, I would like to refund my ticket. Then the people behind the help desk said, sorry, sir, that's not possible. You're not eligible for a refund. He said, yes, I am. Look, I have screenshots, and those screenshots clearly show that I can get a refund. And again, this is, sorry, sir, the chatbot made a mistake. The customer did not agree and went to court. The judge totally agreed with the customer. The judge said the following: I don't care if a human or a chatbot puts texts on your website. If it's on your website, you have to honor it, and therefore you have to refund your ticket. So the next day, the customers refunded and the chatbot went offline. I think this story clearly illustrates that the issue we have nowadays with LLMs. Don't get me wrong, I love my LLMs. I think they're great tools, but you cannot trust them the full 100%. Maybe you can trust them for 80, 90%, but the problem is in the last 10 to 20%. Lucky for us, if you use an LLM to generate code, we can use unit tests to check if the output of the LLM, the implementation, is a correct implementation. So my name is Bouke Nijhuis. I'm the CTO at a company called CINQ ICT, and today we're going to talk about TDD and Gen AI, and we're going to see if this is a perfect pairing. So I created a little schema to show off the way of working. I'm going to start with the happy flow, which starts on the left and then follows the arrows to the right. Afterwards, I will talk about the loops in the model. So let's start on the left with tests. I already told you we use tests as input for the model. So we provide the test to Gen AI and we ask Gen AI to come up with an implementation that will pass those tests. Remember, this is happy flow, so we get a perfect implementation, and we're currently at the block in the middle. Because we're doing happy flow, all tests will pass, we follow the yes arrow, and we're done. If you trust your tests, you have production-ready code. This is how it should work in theory. Unfortunately, we also have something called practice, and in practice, things go wrong. This is why we have loops in the model. So underneath Gen AI, the small loop, I call this the code loop because we're generating code. We need this loop because Gen AI sometimes comes up with partial code or non-compiling code. And that's a problem because you cannot run tests against this. Also, sometimes Gen AI comes up with an explanation instead of an implementation, and that's also not good enough. Therefore, we have a loop until we get working code, working implementation. Let's talk about the big loop on top. Sometimes not all tests pass. If this is the case, we follow the no arrow. We extract the failing test, their stack traces, we feed them back to Gen AI, and we ask for a better implementation, a new implementation that will also pass the test that failed in the previous run. And this is the idea. And again, if you trust your test, this will lead to production-ready code. Okay, demo time. I'm going to give a small demo, but I always ask the audience to make a choice. In this case, Mala, could you take over the screen?
Yes. Hi, everyone. So Bouke is about to ask you a question, but to answer that question, you can use either the QR code to scan with your camera or use the URL displayed on the screen. And then you would be able to answer the question and participate in this quiz. So Bouke, I am changing to the question now, and you can talk about the question.
Yes, very good. So the question is, which AI assistant do you want me to use for the first two demos? You have three choices. The first one is JetGPT. The second one is Claude Sonnet from Anthropic. And the third one would be DeepSeek. And this is a really interesting score because normally when I do this during with live audiences, so when people are sitting in the room, the new kid on the block always wins. So this is the first time, and I would say 5 or 6 times, that ChatGPT wins and DeepSeek has the least amount of votes. So I'm pretty shocked, actually. Luckily, I prepared for all three. The numbers are still changing, so let's give it a few more seconds. But I think we can... Oh, cloud is starting to rise. I would say... Okay, Mala, how much time do we wait?
Another 10 seconds, maybe. And when we are
Okay,
waiting for
another
folks
10
to answer
seconds.
this question, there's an interesting comment in the chat. So, this is something that was mentioned by Chad. So, this is what you're talking about. You are talking about human written test and then Gen AI written implementation. And what happens when both of these things are written by an AI tool? How would that
Yeah.
change the game?
Yeah, I think that's really interesting, but I think we need a human in the loop. Somewhere in the loop, we
Yes.
need a human, and this is why I propose that the human writes the tests, because the tests are the check, the only human part in
Yes.
there. So if you do computer to
Mm-mm.
computer,
Mm-mm.
yeah, maybe we can do it in the future, but then still AI
Mm-mm.
needs input, because where would it write the test upon? It needs context. So maybe you would give it specifications or a Jira story, a user story.
Mm-mm.
But yeah, I like my tests because if I've written my test, like I told before, if the test pass, I know
Mm-mm.
the implementation is a good implementation. Therefore, I prefer human written tests. But good question. Thank you, Mr. Gray.
Makes sense. There's another interesting comment. It's like when at the beginning, when JI was becoming famous, everyone was talking about we want to do fun stuff, not have AI do the fun stuff, and we do the laundry. And I think it's doing the same thing with us now. Gen AI is writing the code, and we are writing the test. So that was
Yeah.
another interesting comment, I would say.
Yeah, I've heard this one before.
Yeah.
Actually, I think writing tests is also writing code. And personally,
Mm-mm.
I don't mind writing tests. I think writing tests is pretty interesting.
Mm-mm.
So yeah, some people will like it, some people will not. For now, it's just a
Mm-mm.
concept, it's an idea to think about how we should use our LLMs, how we can check our LLMs for correctness. But yeah, I
Mm.
see your point. Some people like to code, people like to create algorithms.
And on that note, I think we already have two clear winners, and I will let you take it from here.
Thank you, Mala. Now, as everybody can see, JetGPT easily won. So we're going to do the demo with JetGPT. What we're going to do, we're going to start really simple with something called an odd-even test. And don't worry, during the presentation, the difficulty of the examples will improve or become more interesting. But for now, to show off the procedure, we're going to do an odd-even test. Let me show you the odd-even test just to be sure. So we have the odd-even test here. Notice that we expect a class odd-even called odd-even to be there. It should have at least one method called isEven. If you provide it with an even number, we expect it to return true. If you provide it with an odd number, we expect it to return false. So like I said, no rocket science, just to show off the procedure. So I'm going to copy this and I'm going to go to ChatGPT, which is third in line because I expected DeepSeek, then I expected Claude, but okay, we also have ChatGPT. Please provide an implementation that will pass this test. I paste the code from my IDE and we wait for an answer. Let me scroll down. And there it is. Pretty simple. I'm just going to go. I want to copy it, but the button moved. I don't know why. How do you? Oh, wow. You can make it. Okay, it doesn't matter. I can click it and then I can copy it. Apparently, that's a new feature I didn't see before. That's because people always ask me to use DeepSeek and not ChatGPT. I'll go back to my ID. I go to the test subject. I select everything. I paste the code from ChatGPT. I go back to the test and I run the test. And then we hope for a green check mark. And look at that, we have a green check mark. So the principle works. But hey, I hear you. This was a really, really simple example. So let's step it up a notch. Let's do the same, but then for prime number generation. So I created another test called prime number generation test. And let's make some space. Now we have two tests. And the first one is called under 10. It expects a prime number generator class to be there. It should have at least one method called generate, which takes an integer as input. This integer denotes the upper bound of the prime numbers to generate. So if your input is 10, we expect the generate method to return 2, 3, 5, and 7. So under 50 is similar, but now we have 50 as input, and then we expect it to return those numbers. Again, I'm going to copy the code. I'm going to go all the way to ChatGPT, and I'm going to just paste the code. ChatGPT is smart enough to understand that I'm still asking for an implementation that will pass this test. And we got a network error. That is really nice. Okay, let's retry because there's a nice button over here. Let's put the code over here. Let's hope it's still, it's working. So let's give it a little moment. There will be an implementation here. This will take a little bit longer. It's also pretty slow. Not sure what's happening with JetGPT today. And we have a bug again. Okay, I'm going to switch to Claude, which was the number 2. Hopefully this one will work correctly. Please provide an implementation that will pass this test. I paste the code. And normally Cloud works totally fine. It also seems to be much faster than JetGPT today, which is nice. I'm not really interested in the implementation, so I'm just going to copy it, go back to my IDE, go to the test subject, select everything, paste the code from Claude, go back to the test, and let's run it, and let's hope we get 2 green check marks this time. And look at that, down here, we have 2 green check marks. Woohoo! The principle works. Thank you for listening to me. Have a nice day. Nah, just kidding, just kidding. I'm really happy that the principle works, but there are 2 major issues with this approach. And the first major issue is the fact that it had way too many manual steps. So let me take you through the steps again. I was in my IDE, I selected the test, I went to my browser, to an AI, I typed in a prompt, I pasted the code from my IDE, pressed enter, wait for an answer. Then I copied the code, went back to my IDE, went to the test subject, selected the code, pasted the code, and started the test, waited for the outcome. Just talking about this makes me tired. So way too many manual steps. So what do we do when we have too many manual steps? Of course, we automate steps away. So that was my idea. I wanted to make a tool that did all those steps for me. And that sounds pretty simple, right? How difficult can this be? So I expected it to take me 3 to 5 evenings. It turned out to be a little bit harder than expected, like a real life project. It took me 10 to 15 evenings and a few weekends, but in the end, I had a tool that did all those steps for me. Luckily, I also learned something during this project. I learned that the IDE does a lot of work for you. And of course, I already knew this, otherwise I wouldn't use it. But it became really apparent during this project, and I will come back to this in a few minutes. In the end, I had a tool called the test-driven generator. So of course, I'm going to show off this tool, but before I'm going to do that, I'm going to take you to a few of the little steps that it takes, and hopefully you understand a little bit better why it took me so many evenings. So this is part of the schema I've shown you before, and one of the first things that you do after you read the test file, you have to call an API of a Gen AI. Now, I started building this tool in the beginning of last year, and I was most familiar with JetGPT at the time, so I started out by using JetGPT. So using the API from JetGPT isn't hard, but it's just a little bit of work. And the same applies for interpreting the reply. This sounds really simple. You saw me using OpenAI and Claude, and they make a clear distinction between this is the explanation and this is the implementation. But this is not the case when you use other models. During this time, I also got interested in using local LLMs. And all those LLMs are a little bit different. They're less powerful, and therefore they have different ways to make the distinction between explanation and implementation. So this sounds really simple, but it took me a little bit of time to write a mechanism that would work for all LLMs. Then you have to create a file. Now, I assume most of the viewers are Java developers, and then you know a Java file should have the exact same name as the public class name of your class. So if you say public class X, then your file name should be x.java. So I need a feature to extract the public class name from the code. A little bit of work. Then I have to put this file in the right location. If the implementation from the LLM contains the package keyword, I have to extract the part behind the package keyword and then create the corresponding folder structure in my temp directory and then put the file in there with the right file name. So this is all a little bit of work. Then I have to compile both files. I totally forgot about the fact that you have to compile files. The last time I manually compiled files was about 10 years ago. This is typically something that the IDE takes care of for me. So I totally forgot about the fact that I have to do something for that when you build your own tool. So another evening. Then you have to load both new classes into the JVM. And I also totally forgot about this one. When do you manually load classes in the JVM? You don't do that. The IDE takes care of that for you. Another evening. Then you have to load the test library. So always when I start a new project, I just put JUnit 5 in the POM file and I forget about it. And also I use test scope, but now running the test is not part of my test, it's part of my tool. So it shouldn't have test scope. And I did explicit steps to load this test library. I forgot about the fact that you have to load test libraries when you want to run tests. Then I had to run the test from code. This is not something I've done before. It's possible. It's not difficult, but I had to find out how to do it. I had to build it. So another evening. Once all tests pass, I copy the implementation from the temp folder where I did all my work back to the project where the test file came from, so you can directly use it while using the tool. If not all tests pass, you have to extract the errors. So you get a memory structure with all tests, some failed, some passed. You extract the failing tests, and then you also grab their stack tracers, their output. You feed this back to Gen AI. It's a little bit of work. Also, when you run tests in your IDE, you just press the green button, you get this nice table, and you can see which one passed, which one failed. Now you have to do all kind of messy things in memory structures. Then you have to continue the conversation, so you have to keep track of the context. So you saw me in the browser with OpenAI. The second time when I just pasted the code, it remembered that I was looking for an implementation that will pass this test. This is not the case when you're using an API. And when using the API, by default, it doesn't know about context. It doesn't remember the previous request that you made. So you have to build something for that another evening. And also, I needed proper logging. Remember the schema with the loop on top? Every time when you make a loop, the input will be a test file, multiple lines of code. The output will be the output of the LLM. So you will have an explanation, you will have lines of code. So a lot of lines of logging. You want to keep track of everything that you send to the LLM. You want to keep track of what it answers. So I created a detailed logging in the log file, but a summary on the console. Took me another evening. So hopefully you now understand why it took me a little bit longer than 3 to 5 evenings. During the last few minutes, I told you I started out with JetGPT, but I also got interested in using local LLMs. And I learned two things. I learned that local LLMs are easier and faster than I expected. What did I expect? I expected to be running a local LLM would be difficult. So I expected 20 manual error-prone steps, and then hopefully the LLM works. It turned out it's pretty easy. There's a tool called Ollama. You just download it. You use this tool to download the model and to run the model. It's like the Docker for LLMs. It's really simple to set up. Everybody can do this. Also, I expected answers to take up to minutes. At the time, so last year, I was using an Apple M1 Pro. Then answers took about 10 in the tens of seconds, so let's say 30 or 40 seconds. Nowadays, I have an M3 Max, and now I get answers around 10 seconds, which is a pretty impressive for a local model. There are lots of local coding LLMs available and even more general purpose LLMs. I tried out a lot, but in the end, I settled on using Llama 3.1, the 8 billion parameter one, because that runs pretty fast on my machine. I know there are newer versions of Llama around there, but they didn't really do better than this one for my specific use case. I also tried out the new DeepSeek models, and they also performed similar. So I stuck to my favorite Llama 3.1. So when I'm doing demos in the remainder of the presentation and I'm not mentioning another model, I'm using this one running locally on my machine. Okay, demo time. Yeah, what we're going to do, I first have to do a git reset. I always forget this, so that's why the bullet is there. This is going to get rid of the answers from Claude and OpenAI. So now I have a clean project again. And what we're going to do, we're going to do the prime number generator again, but now not manually, but with a tool. So let's open a terminal. The tool in its current form is a jar file, just from another directory, from another project. Its most important input is a path to the test file. So I'm going to copy the path to this file, and I'm just going to paste it here, and I'm going to press enter. Now notice that we have a test loop. Within a test loop, you can have 5 code loop attempts, and we can have 5 test loops. So in total, you can have a maximum of 25 loops. But hey, look at that. In 9 seconds, it found 2 tests, and both tests succeeded. So we can take a look at the implementation right now, but we don't have to. If you trust your test, you trust the output of this tool. Therefore, we're going to continue. The tool works too, and that's pretty cool, because now I don't have to do all the manual steps anymore. Now I can just use this tool to do the work for me. So now we have such a tool. Let's talk about the implications of having it. How would you add features? Now, in the past, I would just go to my implementation, I would write more code and more algorithms, so I would have more features. But in this idea, the implementation is the area of the LLM, of the AI. So I'm not allowed to touch it anymore. The only part that I'm allowed to touch is the test area. And this is exactly the answer. You just write more tests if you want more features. And this feels really natural if you're used to working in a TDD kind of way. So let's demo that. Let's talk about negative prime numbers. So remember, this number here denotes the upper bound of prime numbers to generate. So if you put a negative number here, you're asking for negative prime numbers. And as far as I know, they do not exist. Therefore, I want to generate a program to throw an exception whenever people ask for negative prime numbers. Now, how would you add such a feature? Simply by adding a test. So let's do that. Public void negative input. And look at that, the one-line code completion from IntelliJ gives me exactly what I want, so I'm going to accept it. And this is not correct. What I want is an assert throws. And again, the code completion comes up with exactly the line of code that I want. I'm going to accept it, and then I will explain it to you. So we have an assert throws. An assert throws takes 2 parameters. The first parameter being the argument that you expect. So in this case, we expect an illegal argument exception. And secondly, you provide a lambda that should throw this exception. So by putting a -1 here, I expect the code to throw an illegal argument exception. So I'm going to rerun the tool. I take exactly the same command. The only difference now is that the file where it points to has 3 test classes. And look at that again in 5 seconds this time. It found 3 tests and all 3 succeeded. Now this time we're going to take a look at the implementation, because I want to see the part of code that corresponds with this test. So let's go to the test. And if you look over here, 3 lines of code, those are the result of the new test that I've added to the test file. So you add features by adding tests. Feels perfectly natural. The second thing is, what about real code? So up till now, we only did toy problems, right? We did the odd even test, we did prime number generation, but I'm assuming most of the people watching this video are Java developers. And probably you have written hundreds, thousands, tens of thousands of tests in your life. You could also use those tests and feed them into this tool. And maybe it comes up with something better that you wrote. And actually that happened to me. So I use this tool to improve the tool. Let me explain that. How does that work? So somewhere in the tool is a class called the code container. And the code container has a few features. The first feature is holding the code that the LLM generates. The second feature is extracting the public class name, so we can use it to write the proper Java file name in a later stage. And the third feature is extracting the part behind the package keyword because if we have that, then we can create a corresponding folder structure. So the second and the third feature are actually extracting text from text. And in a lot of cases, the best way of doing that is by using regular expressions. Confession time, I am really bad at using regular expressions. I think they're really hard. I think they're written for computers, not for humans. And I struggle every time when I have to write them. So I started out by using a poor man's substring implementation, and it worked for a time. But then I added a few more tests, and yeah, it kept breaking and breaking. So I decided I need a proper regular expression implementation. And I decided to use the tool to improve the tool. So let's take a look at the code container test. So there are two tests in here, and the first one is called file name extraction. Notice that I have some small classes over here. Those classes are normal classes, public classes, and random spaces in random spots. And those random spaces really broke my poor man's substring manipulation solution. Then we have the expected answers, and then in the end we have messages. I think having messages with your test is always a good practice, especially for the people who maintain the code after you wrote it. But in this case, you can also put a message there to help the LLM. If you make a clear message of what this test should achieve, it helps the LLM to come up with a better solution. Now, something similar for package name extraction. Again, we have a few small classes here. Notice that we have random spaces again. We have single level packages, multiple level packages, and also no package, because package is, of course, optional in Java. So let's copy the path to this file. Let's go to the terminal. Let's get rid of the last input, and let's paste the path to the file on top. And let's see what happens. I have to warn you a little bit. This is on the edge of what a local LLM can achieve. Now look at that. My local LLM came up with a solution, but unfortunately only one of the two test cases succeeded. We fed this failing test case back to the LLM and asked for a better implementation. This is the feedback loop, and here you see the feedback loop at work. The second time it came up with a proper implementation. Now I have to warn you, I hope it came up with a proper regular expression solution, because there are working substring manipulation solutions out there. But let's see what happens. And actually, I don't care if the LLM chooses one or another. If the tests pass, you trust the output of the LLM. But let's take a look. Let's see what it created for us. Lucky for us, regular expressions all the way. So I use the tool to improve the tool. So during the beginning of this presentation, I told you there are two major issues with the current approach. The first one was too many manual steps. We solved that by creating a tool. But the second one is, what about libraries and frameworks? So we have a tool that's pretty capable of generating plain Java code. But that's not really what we do at our daily job, right? We use libraries, we use frameworks. And in its current form, the tool cannot handle libraries and frameworks. And that's because we only provide a test file as input. And it's pretty difficult to deduct all the libraries and frameworks that you're using from a test file. It's not impossible, but you will never achieve 100%. So I started thinking, which part of my development cycle knows about the libraries and frameworks? And if you think about it that way, the answer is really simple. The build system knows about your dependencies, and therefore it knows about all your libraries and all your frameworks. So I started to create a Maven plugin. Why Maven? Because I have far more experience with Maven than I have with Gradle, but you could also do exactly the same for Gradle. So the idea behind this is a Maven plugin knows about your dependencies. I also expected it to load all my dependencies for me. I never wrote a Maven plugin before, and it turned out to be wrong. It does not. But because you are a Maven plugin, you have easy access to all the dependencies. Actually, it's just a list of paths to jar files or directories. And you can just write your own custom class loader. And then you should have all the ingredients to be able to use libraries and frameworks. So let's try out if the Maven plugin also works. I told you there is a... Oh, no, sorry, wrong thing. The thing I would like to show you is an endpoint test. And another word for this test would be a Spring Boot Hello World test. So the library that we're going to use, the framework that we're going to use will be Spring Boot. And I created a little test for that. Let me show you that. So for people who've never seen a Spring Boot test before, this is how it looks. You can choose to use random ports, and if you do that, it will put the random port in here. I'm using a test REST template because I want to do a REST call in this test. And you can see I'm going to do a get on the root of localhost. And if you do that, I expect it to return hello world. So a Spring Boot hello world test. I told you it is a Maven plugin, so we should also talk about the POM file. And there's a lot of stuff in a POM file, but the most important thing is over here. We have a new plugin called the Test-Driven Generation Maven plugin. And its most important input is a path to a test file. And currently it points to the file that I've just shown you. So this file. Now let's run it. We go to the terminal. We say Maven test-driven generation generate. This is how you call the plugin. And if you do that, you can see from those two lines over here, the Maven plugin just is a wrapper around the jar file. It reuses the jar file. And look at that, build success in 6 seconds, still talking to my local model. Let's see what it created. It created a class that is a Spring Boot application. It is a REST controller. It starts the application. It has a get mapping on root, and it returns hello world. This is more or less how I would have written it myself, but I probably needed more than 6 seconds to type all this out. So, hey, the Maven plugin works. But okay, this was a really, really simple example. So let's step it up a notch. Let's also do another one called endpoint H test. So again, a Spring Boot test, and everything is similar. The changes are over here. So the idea behind this endpoint is we provide it with a birth date, and then we want it to return an age. And let me take you to the examples. So if you're born on the first day of this year, you're 0. If you're born on the first day of 2020, you're 5. If you're born on the first day of 2000, you're 25. But if you're born on the last day of 2000, you still have to become 25, you're still 24. And this is where the difficulty lies in this kind of calculations. Also notice that we have an age endpoint and the birthday should be part of the URL. That's it. Let's go to the POM file. Let's change this in endpoint H test. Let's go to the terminal. Let's rerun the Maven command and let's see what happens. And again, I have to warn you, this is really on the edge of what a local LLM can do. It has to use Spring Boot, which adds another layer of complexity. It has to solve the algorithm, so from birth date to age. And as you can see, it came up with an implementation, but the test failed, so it wasn't good enough. So I'm going to prepare for failure, and I'm going to play with those things over here. So I'm going to uncomment this line. If you do that, if you select the Anthropic family, it will default to Cloud Sonnet in the cloud. So I will not be using my local model, but I will be using a cloud model. And notice that you can also specify models, you can specify timeouts, you can specify which server to use. It's really handy when you're debugging. And you can also write your own prompt. So I'm going to prepare for a new call so we don't have to wait. Maven test-driven generate. This is also probably a right moment to show off the logging. So as you can see, I am using Olama 3.1. You see a timeout over here, part of the prompt. This is the input, the test file that I've shown you. And then here is the first solution that it came up with. Let's see if we can find why it failed. I don't see it exactly, but this looks really difficult. I think it should just subtract the birth date and the current date, but this is probably why it failed, and this is probably why the test failed. Let's see if it did something. Now, you see, no solution found. So it was not able to find one. Normally, what I would do, I would just retry, because retrying is a really viable option when using LLMs. LLMs have temperature. Therefore, every time they come up with a solution that's a little bit different, but it will take a lot of time now, and it's not so interesting to see all those lines of logging. Let's just use a cloud LLM because that's also an option. So the difference now is I'm not talking to my local LLM, I'm talking to a cloud LLM. And to be more specific, I'm talking to Cloud Sonnet. And normally it is capable of coming up with a one-shot solution. Sometimes it takes 2 shots, but look at that, build success. It took 80 seconds, which is pretty long. So Cloud Sonnet is also a bit slow today. Let's see if we can find a solution over here. So let's see what happens. It picked up the part where birthday should be part of the age. It parses the incoming birth date, and then there is a little mistake. You see? It should have said local date now. It should have used the day of today. But this is my mistake, not the mistake of the LLM. I only provided 4 test cases. And the best way to solve this problem is to providing more test cases. Let's say a test case that specifies yesterday, test case that specifies today, or specifies tomorrow. But you can also put hints in the code. And let's do that. Let's see what happens if we do that. So let's go back to the code, which is that's not the code that I want. I want endpoint htest, this one. And let's say hint, I use today to calculate the difference. And let's see if this is enough to come up with a proper solution. If it's not, please believe me, normally this totally works. But this is more of a stopgap solution. The best solution would have been adding more test cases, but that would have taken too much time for this live stream. So let's see what it came up with this time. And it still uses this one. Yeah, sorry for that. Believe me, most cases it works. The best solution would be add more test cases. So the Maven plugin works too, and it's really great because now we have a tool that we can use at our daily job. So what does work well? Plain Java code works really well. The first few demos I've shown you were plain Java code, and it was pretty capable of generating implementation that will pass the test that we used as input. Also, it works pretty well when you have well-known dependencies like Spring Boot, but it should also work pretty well for Quarkus or any other well-known library out there. What does not work well? References to your own code. So the only input that the tool has is the test file. It doesn't know about all the context existing, all the other files existing in your project. And this is solvable, but I didn't solve it yet. I will talk a little bit more about it in a slide called Future. Also, it doesn't really work well with less known dependencies. So those LLMs are trained on information on the internet. If you have a dependency that doesn't have a lot of examples on the internet, probably it doesn't work well with this tool because the LLM doesn't know how to use it. But if it doesn't work, now it happened during the presentation, the first thing I would do is retry. And I explained to you with temperature, LLMs always come up with a little different solution. Second thing I would do, I would check the logs. Maybe there's a bug in the tool. Maybe there is something wrong in your input, in your test file that you use as input. Happened to me one time. There was like a typo in there. And the next thing I would do, I would upgrade the LLM. So I go from a local LLM to a cloud LLM. And you saw me doing that. And if then still it isn't capable of solving your problem, don't worry. At least you have the unit test. Now, let me explain this. In the past, I would write my test, grab coffee, write the implementation. Nowadays, I write my test, run the tool, grab a cup of coffee, and when I come back, in the best cases, I have a solution, and in the worst cases, I only lost a minute. So at least you have the unit tests. So let's talk about pricing. The pricing is pretty non-existent when you're using a local LLM. This is not entirely true. My laptop becomes a little bit warm, the battery dies a little bit sooner, and in the end of the year, your electric bill will be a little bit higher, but you probably will not notice it. You pay a small price when you're playing around with online AIs. So I created this tool, I gave it at multiple meetups, multiple conferences, this talk, and it took me less than 13 euros, which I think is pretty acceptable. It will become pricey whenever you will use this for every test case that you have. But I do believe in the near future, there is a point in which this will be price effective for two reasons. First of all, those LLMs are getting cheaper, faster, and better every week, and literally every week. Secondly, the most expensive part of a software project is the hourly rate of developers. So every hour that you saves a lot of money. And with this money, you can easily pay for all the tokens that this approach will use. Can I use this myself? Yes, you can. I will share links afterwards. On the last slide will be a few QR codes, and you can just play with it. I have to warn you though, it is proof of concept level. Like I told you, I expected it to take a few evenings. In the end, it took a lot of evenings and a few weekends, and it's still not finished. But it is good enough to play with the concept, to play with the idea. So future. Currently, the tool only accepts one test file. I really would like it to accept multiple test files because sometimes we have multiple test files. Currently, you only provide the one test file as input, but you cannot provide context of your project. I think if I would build that you could also add the context of your project, you would get better answers. It would reuse code that's already in your project, so that would make this a far much better tool. Currently, the tool can only work when the answer of the LLM contains exactly one class. If it contains multiple classes, it fails. If it contains partial code, it fails. That's too bad because I think we could make it faster and better if I would also support this. I would love a hybrid mode. So you write part of the implementation and then you leave to-dos for the AI. So you work together to a final solution. Currently, I support Olama, ChatGPT, so OpenAI, Anthropic, and DeepSeek, but there are all kind of interesting AIs out there. I would like to support them all. Currently, it only supports JUnit 5, but what about 4? What about Spock and all the other great test frameworks? I would like to have support for all of them. Currently, it only supports Java, but this principle, of course, holds for every programming language out there. So you could also write this for other programming languages. And my endpoint for this idea would be an IDE plugin. So picture this, you write your test, you right-click, you say generate implementation, you grab your cup of coffee, you come back and you're done. I specifically said my endpoint because I think this idea should be part of Copilot, AI Assistant, or DevOps Genie. I am on the JetBrains live stream, so people from JetBrains, please take this idea, build it in your IDE. For people who do not know what DevOps Genie is an open source project created by the father of DevOps Belgium, Stefan Jansen. And he would love to have this in his project. I would love to have it there as well. I don't have the time to put it there, but DevOps Genie is open source. This project is open source. If you merge it, you have a very good chance to stand at DevOps Belgium next year. So conclusion, TDD and Gen AI is a perfect pairing. The principle works. I've shown off multiple demos in which I gave test cases to the AI came up with an implementation, and all tests passed. The most important thing I can teach you today is check the output of large language models. Lucky for us, by using this tool or this concept, we have an automated way of checking the output of LLMs. Saves you a lot of work. Thank you for listening to me. If you have questions, this live I will be done in a minute, and then you can ask your questions. There are 4 QR codes in the bottom. The one on the left is a link to the slides. The second one is a link to the examples I've shown. The third one is a link to the repo that creates the jar file. And the fourth one is a link to the repo that creates the Maven plugin. Feedback is more than welcome, so please leave something in the comments, or just send me an email, or hit me up on Blue Sky. My handle is in the bottom right corner. Also, last mandatory bullet from the HR department: we are hiring. If you're Dutch speaking and you're looking for a new job, please talk to me. We're always looking for talent. So, time for questions. Mala, can you take it over again?
Hi, Marco. Thank you so much. The session was great. And before we jump on to the question and answer section, everyone watching, please use the QR code on your screen to submit your feedback on the session. You can also use the link that we have displayed on this slide. And with that, let me display the first question. This is by Sagar, more of a comment because you are talking about test and the implementation. So Sagar has a comment that the test can also mislead because the implementation can be suboptimal and it will pass, but implementation might be a bit less code quality relatively.
Yeah, very good question. That's totally right what you're saying, but the idea that I'm proposing is here that we don't really care about the quality of the code, because the test pass, and I don't mind if it's bad quality. If the test pass, the output is of the tool, or the output of the generated code is good enough for you. Sometimes I get the question, but what if it generates a suboptimal solution, so it doesn't perform? And then my answer is just add a performance test to there. Add a test that measures how fast it is, and say how fast it should be at least. And this is how you can play with that. I also gave the example of sometimes the LLM came up. I showed you the example with the code container test. So I wanted it to come up with a regular expression example. But actually there are, how do you say that, solutions out there that don't use regular expressions. And that's fine with me. As long as my test pass, I trust the output of the large language model.
That makes sense. We have another question, so this is, can't we consider that it is better for the AI to rather write the test because it won't forget test cases? If you are human forget test cases, then the implementation might still be wrong. I think there's this kind of questions. There are multiple questions on this approach, like whether to write the test first or have the AI generate the test or the implementation.
Yeah.
I guess that's. Mm-mm.
Yeah, I think this. I like it this way. So you write the test and the computer writes the implementation, because then you have control. If you let the computer write the test cases, the LLM, then you still have to check those test cases, because you cannot trust an LLM up to 100%. And of course, you can also not trust yourself up to 100%. But I think we as developers should at least have a lot of test coverage. And this is a way, yeah, I like this way better. And of course, there's nothing wrong with doing the other way around. If you prefer to write your implementation and then let the AI generate test cases, that's also fine. But I like this approach.
That makes sense. There are multiple approaches. So anyone, whatever works with the developers, they can go with that. So there's another comment. There's a classic exercise called Evil Coder, where one person tries to create test one by one, and the coder tries to do the best to provide a minimal implementation, leading to a dead end. So this is more of a comment.
Yeah, I heard about this one as well. It's pretty interesting. So yeah, I think if you do this, you don't have enough tests. But maybe not entirely true.
So there's another comment, question by Kenneth, and he's asking, it could be great if you could give your tool a common lib with utils and whatnot that it can use. Also, does it also use existing code and objects?
Yeah. Yeah, I handled this during the presentation. Unfortunately, it does not yet, but I would like to find the time to implement this, but it shouldn't be that difficult. And if you just give it your entire project context, including all the files, it knows about your existing code and objects, and it can reuse them.
So there's another question regarding the tool that you used. When working with ChatGPT AI, API, you can write it to with different role system, assistant, user. Do you use such roles in your tool?
Yeah, currently I do not. I'm a really simple user. I don't also do not do a lot with prompting. I'm root prompt and do your thing. So currently I'm not using system assistant user, and still it works pretty well. So probably it can only get better when I start using those things.
Okay, now that we were talking about, so a lot of questions have come in. Okay. So this is another question. I'm not sure whether you have used uh, this to generate your test.
Yeah, I know what
Um,
Kirking is. Kirking is, I think it is like a BDD, so behavior driven design domain and exactly style test. So
Development. Uh,
yeah, development. I did not use it, but I think it will work as well because you still have tests that you can run afterwards, and that's the entire idea. And you use the test as input, but also to check it afterwards for correctness. And I don't mind if it's a unit test or a Gherkin test or a performance test or maybe even another test, as long as you have something automated that can check the output of the LLM. I think go for it.
That makes sense. Well, I'll take just one or two more questions because we're running out of time. So, yes, that's right, that we cannot try test for every edge case. I remember attending Kenneth Cousins' session. I'm missing the name of the library that he used, but he used a library in which he would generate the test for the use cases for the test. And oh my God, that was an amazing library. And he could specify that, okay, this is what I need. And then it would generate test with exhaustive values. So that was very helpful. I'm missing the name of the library. I would definitely post that in one of the comments for the video. Um, okay, so
I,
the
I would like to
other.
comment to this. So somebody says you can't write tests for every edge case. Yeah, true, but that we have the same problem when you build the implementation yourself, right? So
Yes.
yeah, and how do you make sure that your implementation will handle every test case then? Then you have to do it on fate or something like that. So I think this is a difficult comment.
There's another question. How would you leverage the tool to improve legacy code or hunt for bugs?
During the demo, you saw me using existing tests. So I fed it to the tool and it came up with a solution. So what you can do, if you have the test, you can just overwrite the legacy code, right? So you don't have to use the old code anymore. Hunt for bugs. Yeah, what you can do, but I'm not sure if this is useful, you can compare the output of the tool and your own solution. But yeah, if they have totally different solutions, then it's really difficult to hunt for bugs. But if there are only small changes, maybe it will find bugs. Um, I, I I never used it in this area, so I don't have a better answer. Sorry for that.
This is the last question that I want to take, and then I think the similar questions like uh, on the same thing. So yes, the last yes.
Yeah, is it necessary to hard code expected parameters? No, it's not necessary. If you just, I don't mind as long as the test runs. It's like normal programming. So if you have tests and you can run those tests, then it's fine. I don't mind if they're hard coded or dynamic. That's totally fine as long as you can run the tests.
So maybe the last question. Do you think the same kind of tool could work for UI test? And then we close the stream. Sorry.
Yeah, I think it would work for every kind of test. As long as you can run the test afterwards, you can check if the output of the large language model is correct. So yeah, I am pretty sure it also works for UI tests.
Thank you so much. A lot of questions coming in, but some of them are kind of similar to the previous ones. And yes, so on that note, thank you so much. It was a great session. And everyone watching, I would encourage you to use the socials links, which are displayed on the screen right now, to connect with us and to connect with Bouke if you have any questions. And Yes, thanks everyone for watching, for asking questions, for participating, and for learning with us. Thank you so much, Bouke, for presenting the session with us. If you have any closing comments before we actually close the stream.
I also would like to thank everybody for listening to me and for all the great questions. Enjoy the remainder of your day.
Thank you so much. And we have the next live stream in March where we have Jose from Oracle talking about stream gatherers. Do not miss the session. It's going to be a great one. And until that one, bye bye.